on your study sheet, you're going to have grouping, and now you're going to have permutations where you have identical objects, things that are exactly the same. Letters, marbles, balloons, right? If you have like 5 red balloons, do you know the difference between this red balloon or the other red balloon? You don't really, right? Marbles, the same thing, this one and this one. So we're gonna have to, if you cannot tell them apart, we need to divide out the repetition. We need to not count the fact that, you know, that permutation exists. We don't want to double count because we can't tell the difference. Okay? So I'll say this. Identical objects would be things such as marbles, shirts, letters, balloons, etc. Would people wearing red shirts be identical? If the question said people wearing red shirts, would you be, oh, they're all wearing red shirts, but then you have to think they're people, right? We're all unique. So that this would not apply to people being rearranged, even if they wear the same color shirt. Don't fall for that. It has to be something you cannot distinguish. Okay. People wearing the same color shirt, right, would count as unique and distinguishable. Okay, there's no repetition or no identical objects here. So, how do we deal with this? I have my pathways ready here. There we go. Pages are off. So this is the formula for permutations. You apply the same logic as before, like if you're rearranging letters or people, not people, marbles or anything like that, it'd be the total number of objects. So you still go n factorial. The idea is that the amount decreases every time you fill a slot. A stands for the number of the first set of identical objects, so you go A factorial. B is the second set of identical objects, B factorial. And the dot 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 just means you would continue doing this for as many identical objects as there are. That's what this means. Okay? So let's do a couple of examples. You can wrap your head around this part. So for example, how many ways can the letters in the word eyes be arranged? Count. 1, 2, 3, 4. 4 letters. This is where I would like highlighters. Do you see letters that are exactly the same? You should see the E there and the E there. There are 2 E's. Okay? So I made sure that every word you did so far didn't have any repeated letters. But now it's going to change. Now we can do applied, for example, because it's got 2 P's. So you would still go like this. You would go 4 factorial divided by 2 factorial. So you divide out the repetition. Okay. 4 factorial is 24. 2 factorial is just 2. So there would be 12 arrangements. And why is that? This is the reason. If I were to say eyes, like this is actually arranged, and let's say we want to distinguish them, we want to put E1 and E2, right, to tell them apart. If you were to put this E up front and this E over here, they're technically not 2 different arrangements. They are actually exactly the same. That's why we divide out the 2 factorial to get rid of that, to not count it again. Okay? Right? Exactly the same. Okay? So we divide out repetition. This is probably worth highlighting. So, a couple more here. This is a very classic question. They may honestly just have one page, a whole page taking up, like cactus. How many ways can you rearrange the letters in that word? You should first and foremost count 1, 2, 3, 4, 5, 6. So n is equal to 6 letters. And you've got 2 C's. Okay. There's a C there and a C there. Everything else is doesn't show up again. So 2 C's. I'm going to highlight the 2 E's up here as well. 2 C's. So normally, I will show you this a little differently maybe. This is what we used to do. We would go 6, 5, 4, 3, 2, 1. However, now we have to make note that there's a repeated letter. So the whole thing is divided by, in this case, 2 factorial. Okay, so you end up with 6 factorial over 2 factorial, like that. What is 6 factorial? If you have it on your study sheet, that's 720. 2 factorial is just 2 times 1. That's 2, so 360. So normally, you would say 720, but because we've got the 2 C's there, it's actually half of that in this case. We're not counting those as well. Next, eyeballs. Count 1, 2, 3, 4, 5, 6, 7, 8. Right? N is equal to 8 letters. And what do we have? We've got 2 E's. So make a note of that. 2 E's. What else is repeating? The L's, right? There are 2 L's as well. So 2 E's. This last exam, they had like a super long word. I think it was like 18 letters long and with a bunch of repeats in there. Don't let that scare you. It's the same, right? You just approach it the same. Just count. And then you got to go like this. You got to just go 8 factorial. And underneath, you'll have 2 factorial times 2 factorial. In this case, you've got 2 repeats. So you just multiply them for as many as you have. That's where the dot, dot, dot came in, right? So 8 factorial divided by 2 factorial times 2 factorial. 8 factorial is 40,320. 2 factorial and 2 factorial, that's really just 2 times 2, which is 4. And that ends up being 10,080 ways. Okay, that's how you would do it there. So that's where the formula comes in, right? P is equal to n factorial divided by a factorial, which represents the e's, 2 factorial, which represents the number of L's in this case, and it just keeps going like that. Okay, moving forward. I made a bit of a list for you here on the side. Perm's checklist. Perm's checklist. You want to look for, are there any restrictions put on us? Like, does the first letter have to be an L, a Y, a Z, whatever? Okay? Vowel. Does it have to be, right? Then you want to look for, is there any indication for grouping? At the very end, you want to check for identical objects. You always want to check for that. So these are my three things that I check for moving forward. Okay, let's try a few. So I'm going to ask you to come to 31. I'm going to ask you to try page 31, just the first question here, Canada, and then I want you to do the one right beside it, Mississippi, on the other page. Page 32 at the top. I want you to figure out how many permutations there are. Pay close attention to this. When it says no restrictions, can we ignore the fact that there are repeats in there? No. You always divide out repeats. Even if it says no restrictions, it just says, it's basically saying no additional restrictions. Like no that the first letter has to be this or that. So figure out how many ways you can rearrange Canada, and then Mississippi. Go to 32 and see if you can get those two right. And then we'll do the other restrictions that come after. I want to do pathways before we go yet. Pathways are fun. Okay, Canada. You've got 1, 2, 3, 4, 5, 6. N is equal to 6. I think I got that one right. There are 3 A's. That's all I can tell that is repeating. So you just go 6 factorial divided by 3 factorial. Oh, don't forget, if I ever ask you to evaluate, how would you evaluate this? You break down the largest, right, the largest factorial here, and then you stop when you see an equivalent factorial at the bottom. So don't forget that. This is what we call evaluate. We'll do a bit more of this later on. I'd rather cover these topics that are heavier, I would say. So there's 120 ways to do that. 120 ways to get the permutations here. Let's do Mississippi on the next page here. Please correct me if I get this one wrong, because I just did it while I was talking to you. So N is equal to 11. 11 letters. 4 S's. 4 I's. And 2 P's. Right? Okay. These ones always give me a headache. I always feel like I'm miscounting here. It's like, how many I's? So we've got 11 factorial divided by, it'll be 4 factorial times 4 factorial times 2 factorial. And I don't have an answer. Is it possible to do this? Yeah? Oh yeah, no problem. So if you want to do this with your calculator, please be careful. If you just go divided by 24 times 24 times 2, you're going to get the wrong answer. So if you want to do this all in one shot, you got to go divided by bracket 24 times 24 times 2. Close the bracket. That's what you should be getting. 34,650 ways. So even though it's a really big word, lots of letters, there's so many permutations that we're not counting because you move the S's around, like that's not a new permutation. You move all the I's around, that's not a new permutation, right? So we're not counting them. Okay. So keep that in mind. Let's deal with, if you know this part, I'm happy. If you see a word with doubles, boom, you got it, I'm happy. So I'm going to go to pathways. You're like, what about the rest? We'll do that on Monday. I promise I come back to that on Monday. So let's keep going. We're going to skip a few pages until you see these blocks here, the pathways. On page 36, pathways. Pathways has everything to do with repeated items, guys. Everything. Okay? When you're asked how many different pathways there are from point A to B, it is permutation. It is a permutation question dealing with identical objects. Okay? Movements to the side, east or west, are considered identical. Movements up or down, north or south, are considered identical as well. There are two methods to solve pathways. Okay, you should have the formula. I would strongly suggest you have this formula on your study sheet. Believe it or not, it looks crazy, but this is exactly the same formula I gave you just a little while ago. What was at the top? N. And then we divided out the repeats, and we divided out another set of repeats, right? So moving side to side and moving up or down would be considered repeated moves. Okay, so we divide them out. And the second method is the counting method. And I'm just going to show you examples how that works. So we're going to use the counting method, and then we're going to verify with the formula. Okay, so here we go. Case 1, there's only one route to get there. So how many ways can you get from A, from here? So you got to be very careful where they start. From A to B, because sometimes they go up this way. In this case, we're going from A to B. Assume that we can only travel north to south and west to east, right? So we can only go this way and this way. There's no diagonal cutting across the block, okay? Use both methods. Let's do formula first. So path formula. Have some highlighters ready for this one. So number of paths. Here's my, I'm going to use yellow for the total number of paths. So you start here and you count. 1, 2, 3. There are 3 horizontal. Keep counting. 4, 5. So how many blocks am I traveling in total? 5. And you slap a factorial on it. It's 5 factorial. However, we're going to divide out the number of vertical. Let's do horizontal first. From A to B, how many are you moving sideways? 1, 2, 3. You're moving 3 horizontally. So you go 3 factorial and give it that color. Match the horizontal movement to this. And I'm going to make an arrow down here. This is my horizontal movement. And how many did you travel vertically? 1, 2, right? And we're traveling this way. So you're going to go 2 factorial here. And the total is going to get the yellow, right? In my case, that's the total. 5 factorial, you have that on your study sheet already, hopefully. That's 120. 3 factorial is 6. 6 times 2 is 12. So there are technically 10 ways to get from A to B. There are 10 ways. So here, if I could, right, going straight down and over, that's one way to get there. Going just one block down, then over to the right, then down, that's another way to get there. So if you were to count every single way to get from A to B, in this scenario, there are 10 unique ways to do that. Okay. Here is where you do the counting method. If you like to use the formula every time, you go for it. It works beautifully. You just count total, then you figure out how many vertical boxes are there, how many horizontal, and you just divide them out, you get your answer. But this is how you count. You start here, you put a 1 going horizontally at every corner, you put a 1. The idea is to get from here to here, there's just one way to get there. Same thing from A to this corner right here, there's only one way to get there. Same to this corner, so there's 1 all across. Same going straight down, there's a one way to get there, one way to get to this corner. And now it starts changing, okay? So I start like this. 1 plus 1 would be 2 to get to this corner here. Before we continue, would it make sense that there are only 2 ways to get here? It's one way and another way. There's only 2 ways to get there. Then you go 2 plus 1 gives you 3. 3 plus 1 gives you 4 to get to this corner. There's 4 ways to get to this corner right here. Then I go and start with this one again, so you always add diagonally. 1 and 2, there are 3 ways to get to this corner. 3 and 3, 6. 6 and 4, 10. And isn't that what we calculated? That is our 10 right there. So it works. Try one more. I'll show you a trick on this one. If you had to use the formula, we're going from A to B, right? Where is A? It's down here. So listen carefully. It doesn't matter if you count this way and then over, or over and then sideways. Just make sure you count the total. So there's 3 here, 4, 5, 6, 7. So 7 steps that you were to take going, if you consider vertical and horizontal movement. So 7 factorial. And then you have to figure out your, I want to make sure I match it with the top. It really wouldn't matter, but you've got 3 vertical. So that's my 3 factorial here. I'm going to try to keep it consistent with the top. And you've got 4 horizontal. 1, 2, 3, 4. So I'm going to already highlight that and then just write over it. Do you see a pattern? This is pathways, right? You had 5 factorial, right? And then you had 3 and 2. It adds up to 5, correct? That you should observe that. Then you've got 7 factorial here. If you think about it, 4 and 3 adds up to the 7. So that's good. I'll give you the answer here. But before we go, we're going to do the counting. Because I need to show you the trick here that I think you should apply when it's one of these guys. Because it messes everybody, it messes students up counting upwards. So I turn my whole booklet upside down. That's what I do. Okay, you ready? So it's 35. So I want A to be up top like this. Okay, so I want A here and going to be there. So you go 1, 1, 1, 1. Same along the side here, 1, 1, 1. And then you start adding. 1 and 1 is 2. 2 and 1 is 3. You got to be careful, don't rush. Because if you get even one wrong, the whole thing just derails. 1 and 2 is 3. 3 and 3 is 6. 6 and 4 is 10. 10 and 5 is 15. Back to this. 1 and 3 is 4. 6 and 4, 10. 10 and 10, 20. 20 and 15, 35. See, use the counting method, and you got 35 as well, just like we expected. Okay. You did the exact same thing as the formula, right? You came up with the exact same answer, just using different methods. I would not suggest this one a whole lot because you're gonna see it gets a little, they get bigger, and if you even make one small mistake along the way, it kind of backfires. But I have a lot of students verify their answer using this method. Like, did I do this right? So they do the work inside, and that's just fine. Okay, so what I'm going to say is this. For Monday, make sure you know that when there's a word with repeated letters or vowels or whatever, that you need to divide that out. And know how to do a simple pathway question. I'm going to ask you to try. I have different ones there. Oh, I don't have a simple one. I don't have another simple one. These are simple. Seven minutes. I need to do another one before we go. Because these are the ones that are going to be on the exam. This is the type. I just had to start with those ones. Sorry guys, I know it's Friday, but next week is short. So if you don't mind doing this with me here, go to 37. And what's happening here? You're going through a bottleneck. You're going through a bottleneck. So watch this. I'm going to use the formula here. We are going from A to B. Okay? First step is going to go from A to B and B to C. What does and mean in this unit in particular? Operationally, it means multiply, right? And so let's do A to B. That would be 4 factorial. I'm not going to use highlighters now, guys, okay? So from A to B, it will be 1, 2, 3, 4. 4 factorial. How many boxes are we moving sideways? Dos, right? And how many up and down? 2 again. Put this in brackets to separate it. And how many boxes are you traveling from B to C in total? You go 1, 2, 3, 4, 5, 6. 6 factorial. Over. How many sideways? 4, right? How many up and down? 2. And this is how the cookie crumbles, guys. The way the cookie crumbles. So you got 24 here. This is where having your study sheet with the factorials ready to go will make your lives so much easier. 6 factorial is 720. 4 factorial is 24. Times 2 is 48. Use your calculator if you must. There's nothing wrong with that. 24 divided by 4 is 6. 720 divided by 48 is 15. And now that you've got your whole number, you should get a whole number, by the way. If you get decimals, check. You made a mistake. You should not get decimals. Okay, for today, I'm just going to ask you for homework. I'm just going to ask you to do one question like this. So how about this one here, homework? It's got another bottleneck here, as well as page 39A. Page 39, question A. On top of everything we've done, make sure your study sheets are filled in with the pertinent formulas that we've learned today. Okay, so I'm not asking a whole lot. I'm just asking you to try one of these. maybe review it, like flip through your notes before next week so you're ready to go when we come back, okay? Thank you guys.
2 extra studies.